All right, I want to talk a little bit about the central limit theorem. And we're just kind of continuing to build on what we have been doing through Module 4. We talked uniform distribution, then the standard normal distribution, and the normal distribution. And then we have just a minor adjustment here on it. So give a little context to the story here. It says CNBC reported that the mean annual cost of auto insurance is $1,033. Assume the standard deviation is $291. And that should be the population is normally distributed. You take a simple random sample of 65 auto policies. Find the probability that a single randomly selected value is less than $977. You can assume the population is normally distributed. Now this question is very similar to what we've been doing. It is exactly what we've been doing, sorry. The next one down, it says find the probability that a sample of size n equals 65 is randomly selected with a mean less than $977. And here's the new adjustment for the central limit theorem. So I'm going to get a little snip here of our question, maybe. And then I'll head to Excel and show you how I would do the work here. And we'll talk briefly about what all is happening. So for the first run at it, the mean annual cost, mu, $1,033. The standard deviation, that's sigma, $291. And the population is normally distributed. You take a simple random sample, so this is a new thing. We have 65 auto insurance policies. Now, for part A, or the first question here, it says find the probability that a single randomly selected value is less than $977. So these things need a picture, and so I'll draw a picture for this one. And so I've got a normal distribution, I've got a mean of 1,033, a standard deviation of 291, so I could subtract 291. But my 977 is going to be somewhere over here. And I'm looking for this probability. So this is all pretty run-of-the-mill. And so for the first one here, an individual value of x less than 977. I'm going to do a normal distribution. I've got 977 as my person of interest. I've got a mean of 1,033, a standard deviation of 291, and true gets me the area to the left. So we've got this 0.4236, and the 6 is followed by a 9, so I'm going to round that to 0.4237 as my answer for the first one. Now this next one is sort of the adjustment for this section here. The central limit theorem is what we're going to be using here, and what happens here is if we draw a sample of n equals 65 and we keep taking samples, we can sort of get a normal distribution from data that isn't quite normal, but there's some adjustments to it. So we're talking about means now, bunches of means, and taking means of means and things like that. And so the central limit theorem has some changes. We get a standard error of the mean, and let me grab my pen. What happens here, as we get lots and lots of these values, the mean of all of our means will go to the mean of the population. So our mean of all of our means, and I think we designate this is central limit theorem stuff, we abbreviate it CLT, but our mean of all of our means is going to approach the population mean, which is what we want, sigma. The standard deviation of all of our means is going to approach the standard deviation divided by the square root of n, and this is kind of the standard error of the mean, and by kind of it is error of the mean. Easy for me to say, more difficult to write. Anyway, but essentially we get a new standard error, and I'm going to calculate what that is here. Oops, I need to go to the draw and grab this. So our new standard error is going to be sigma over the square root of n. So that's sigma divided by the square root of n. And I'm just clicking on those. Yes, I'll accept this correction. So what happens here is our standard error sort of replaces the standard deviation. So here we have a distribution, and the difference here between the mean and this standard deviation is $291. But in our new distribution for the next question, like part B, we'd still have a normal distribution. We'd have our mean in the middle, but one standard deviation away now is like $36. So 977 would end up being closer to 2 standard deviations away. And from what we know about normal distributions, 2 standard deviations is very, very different. So for the second question, the probability here that x bar is less than 977, we have a little bit of an adjustment to make because our standard error, our standard deviation, gets changed. So this is a normal distribution, still handle this the same way. 977 is still that thing of interest. The mean, 1033, but the standard deviation now becomes the standard error of the mean, and I still use true. Now you can see there's a big change in probability here. It goes from 42-ish% to 6%-ish. So when I round this to 4 decimal places, 603, the 3 gets followed by a 9, so it's going to go up. And so we have a huge change in probabilities here. And it's because of this adjustment in our standard deviation. So we still use the same process, but when we're looking at x bar, a mean of means, sample means, bunches of those, it makes the data set get a lot tighter together. So we have kind of a new picture here. So notice how much smaller this one is. Now, you might have some questions that have some stuff about using Desmos. I meant to get rid of that, and it didn't necessarily all happen. So please, I'm expecting you to use Excel or the TI-84 calculator, not Desmos or StatCrunch or some of those other things that may or may not be recommended. So pay attention here. If we're dealing with a sample size and sample means, here x bar less than 977 versus just x less than 977, these change significantly with the central limit theorem. And so this is the central limit theorem as it applies to means, and I'm going to make another video discussing how the central limit theorem and when it applies to proportions. So be looking for that as it comes out. Now I just did one example here because it took a little bit of time, but we can still have the area in between, we can have the area to the left, and we can get scores along the bottom. So maybe I'll do a few more examples for you as we get rolling. Anyway, good luck. I hope this helps. The central limit theorem as it applies to means and standard deviations of populations. Be on the lookout for the next video talking about what happens with proportions.